the focus of this video is about a function versus a relation. So you've just gone through kind of a function machine and the function notation. So now let's talk about how not everything is a function. So that's kind of the important message here. So a function is a set of ordered pairs where every input has only one output, whereas a relation is just a set of ordered pairs. So if you take a look at this input-output, like when you put in 8, you got 10, so that worked. When you put in 16, you got this specific -3, etc., etc. So you can see that every input transferred to its own output, right? However, when you came over to, let's say a relation, this 8 went in, and one time it threw out 10, and the next time it threw out 0. That's a problem, because essentially it kind of breaks down the function machine if you think about this. So if you throw in 8, how does it know when to spit out 10 and when to spit out 0? Big problem. And so because there are 2 outputs wanting to come out for this one input, that kind of breaks down the machine and makes it not a function, more so just a relation. Just there's some ordered pairs. So that's kind of what we're kind of maneuvering through right now. So the same thing I just said there, when you think about, you want to put one thing in and always get one thing out, okay? Never putting one thing and getting multiple different numbers to come out. That would be a problem, okay? So this kind of means a relation pretty much has a repeat or repeated output values is another way to put it, okay? So that would be, that would tie you to a relation. All right, so let's take a look at a graph. How does that impact a graph then? Well, if you think about your input is your x, right? That's what we, when we had like f of x equals, let's say 3x plus 4, like we had in the opposite video, we would substitute out this x and put like a 1, and that meant we were going to plug that 1 in for x. So our input are our x values, and our output are our y values, because output and y are the same thing. So when you take a look at this graph, I see 1, and then I see -1, 2, 0, 3, 1. I'm seeing for every x value, I'm seeing an output value, right? That's through this graph here. When I come to the graph on the right, I see that at 1 there is 0. At 2, this input value, the problem is that this function machine would have a problem, because again, if I draw this function machine, if I throw in the number 2, it sometimes is going to want to throw out 1 and sometimes throw out -1, which is a problem. So this would be an example of a relation, whereas this is an example of a function. So not all graphs are functions. Some are just relations. And this is a big deal because it depends on how you can graph things. It's important to know what you're kind of dealing with. So this method of figuring this out, this has a specific name. It's called the vertical line test. So when you are given a graph and you're trying to determine if it is a function or not, you would do what is called the vertical line test, which essentially is drawing a whole bunch of vertical lines through the graph. And when you do so, you are looking for one thing in particular. You are looking to make sure that the lines do not intersect the graph more than one time. So for example, in this graph on the left, which we know is a function, all of my very yellow lines, very gold lines, have intersected the original graph only one time. However, the graph on the right, in each of my gold lines, it has intersected the graph twice, which makes this not a function, okay? So for it to pass the vertical line test, it means it only intersects once. VLT is short for vertical line test. Whereas in this case, it failed the test because it intersected more than once on a VLT. Okay, so and it only takes one time. Let me be clear. Like, it doesn't have to happen every time. One time it doesn't pass, or it crosses through multiple, then it doesn't pass. So on this next one, maybe take a minute and see if you can figure out which of these out of these 12 would be functions and which would be relations, and maybe label them as F or L or R, just to see how you do. Push pause now before I kind of go through them, just so you can check. Okay, so with one, if you think about this, this is a line. This is not going to curve back around. This is absolutely a function. Same thing here. This isn't going to curve back around. Number 2 is a function. This one gets tricky for students because it looks like these arms of the function are going to start going up straight, but they aren't. It's a curve, and it will forever be a curve. So these, while it's passing through once, will only pass through once, and it is a function. When we skip down to 4, we can see that it's curved, but it's also on its side, and it's intersecting twice. This is a relation. Same thing with the circle, definitely intersecting 2 times in the top and the bottom. This is a relation. And the next one, if I draw my lines, I'm only intersecting 1 time every time. The second set of 3, this would be 6, 6 is a function. On number 7, again, creating these lines because those are diagonal, we're good. This is also a function. This graph is a relation because of the curve. Marking these through, never gonna cross through more than once. This is a function. Function. We saw this already. This ellipse is a relation, and because of these vertical lines right here, this is also a relation. Okay, so anytime you see a curve, and the bottom of the curve is not, so if you see a curve and the bottom is a function, there's a likely chance that the arms, even though they look like they're straight they're going up and down, they're going to stay curved. So the top usually stays curved, usually continues to curve. So be careful there. So that's the only thing that I see a lot of students kind of make mistakes on, is something like this one, okay? Is that if it's curved down here and it passes, these arms are not going to end up going vertical. It would make it not a function, which is a big problem, okay? So just keep in mind with functions like that, that it will remain a function. You're looking for more vertical lines like the one down here, all right? As always, if you have any questions, come see me.